Hello, beloved students. It's time for our scheduled chemistry lesson once again. Please make yourself very comfortable. We shall soon be through. Our topic for the day is bases. We shall consider the following: bases in nature, bases in household substances, classification of bases, definition of bases, physical and chemical properties of bases, and lastly, uses of bases. Let us start in earnest. Bases in nature. Quite a lot of natural substances contain bases. Examples include 1. Nuts and legumes, and 2. Urine. Can we write down this short activity? And as usual, I will expect you to do it after the lesson. Create a list of 5 nuts and legumes, since we said they contain bases. Let's proceed to bases in household substances. The following household substances contain bases. 1. Baking powder, also called baking soda. 2. Toothpaste. 3. Antacids. This is a substance used to treat indigestion and burning sensation in the stomach. 4. Laundry soap. 5. Toilet soap. 6. Alkaline batteries. 7. Borax. 8. Hair dye. And 9. Pesticides. Shall we proceed to classification of bases? Bases, like acids, can be classified as organic and inorganic, strong and weak, concentrated and dilute. Organic and inorganic bases. Organic bases are those found in naturally occurring substances. Quite a number of them have been synthesized. A common example is pyridine. Please don't bother yourself about the chemical component of pyridine. It is beyond your level. Suffice for you to know that it is an example of an organic base. Inorganic bases are mostly man-made. Examples of inorganic bases are 1. Sodium hydroxide, also called caustic soda. 2. Magnesium hydroxide. 3. Calcium hydroxide. 4. Sodium trioxocarbonate 4. 5. Sodium hydrogen trioxocarbonate 4, which is the major content of baking powder. And 6. Potassium hydroxide, used in the production of toilet soaps. Let us proceed to strong and weak bases. A strong base is one which ionizes completely in solution to produce a lot of hydroxide ions. Sodium hydroxide is the commonest example of a strong base. A weak base does not ionize completely in solution. It produces limited amounts of hydroxide ions. Ammonia solution is a weak base, and you need to know that your urine has a high concentration of ammonia. Let us consider concentrated and dilute bases. Concentrated and dilute solutions of bases are obtained after known quantities of the base have been dissolved in water. Please let's consider something very important. It is bases and alkalis. An alkali is a soluble base, that is, a base that dissolves readily in water. This means not all bases are soluble. All the bases given as examples under inorganic bases treated earlier are alkalis because they are soluble in water. Before we time out, please write this activity, and as usual, I will implore you to do it after the lesson. Visit a shopping mall. Go to the section where household products are sold. Create a list of toilet and laundry soaps, detergents, toothpaste, hair products, and cleaning liquids. Write the name of the base used in each. From the pharmacy unit, write down the names of different antacids since they contain magnesium hydroxide. We'll time out here and come back later. Welcome back. I hope you are better refreshed to start the second segment of this lesson. We shall start with definition of bases. Bases, like acids, can be defined in three ways. Number one, Arrhenius definition. Number two, Bronsted-Lowry definition. And number three, Lewis definition. Let us start with Arrhenius definition. Arrhenius defines a base as a substance which, when dissolved in water, produces hydroxide ions. Bronsted-Lowry defines a base as a proton acceptor, while Lewis defines a base as an electron pair donor. Let us proceed to physical properties of bases. Number one, bases are slippery to touch. That means when you touch bases, you feel this soapy sensation. Number two, bases are bitter to taste. As usual, I will sound a note of warning. Please never taste anything in the lab, even when you are told it is a base. Number three, bases change, or rather turns, moist red litmus paper to blue. And number four, concentrated bases are corrosive. By now, you should know the meaning of a corrosive substance. That is, a substance that gives a burning sensation when it comes in contact with your skin, or any substance. Let us continue with chemical properties of bases. Bases react with acids to produce salt and water only. The reaction during which a base reacts with an acid to produce salt and water only is called neutralization. Neutralization. Number two, bases react with ammonium salts to produce ammonia gas. Before we time out here, I will give you another activity. Please do it after the lesson. Write balanced equations of reactions to show the reaction of any two bases of your choice with acids, relevant acids to produce salt and water only. Later, when we talk about salts, you will understand this better. But this will prepare you ahead of that time. We'll be timing out here, and later we will come back to finish with uses of bases. Thank you very much. You are welcome back to the last segment of this series of lessons on bases. And like I did say when we were timing out the last time, we shall conclude with uses of bases. To do this, we will pick specific bases and enumerate their uses. We shall start with ammonia solution. Ammonia solution is produced by dissolving ammonia gas in water. It is used to produce, number 1, fertilizers, number 2, plastics, number 3, hair dyes, number 4, degreasing agents, that is substances used to remove grease, and number 5, it is a stain remover in fabrics, especially in laundry. Number 2 base that we shall consider is calcium hydroxide. This is used in 1, manufacture of cement, 2, neutralizing soil acidity, and 3, production of bleaching powder. The third example of base to be considered here is sodium hydroxide, also called caustic soda or caustic alkali or lye, L-Y-E. It is used for production of 1, laundry soaps and detergents, 2, industrial cleaning materials, 3, drain cleaners, and 4, paper. Number 4 base, magnesium hydroxide. It is used to manufacture 1, toothpaste, where it acts as acid neutralizer in teeth. 2, it is used to manufacture antacids, where it acts as a neutralizer of stomach acidity and relief of indigestion. Number 5 base is borax. It is called sodium tetraborate. Please don't bother your head with the formula. It is used as a preservative, antiseptic, and fungicide. Number 6, baking powder or baking soda, which contains sodium hydrogen trioxocarbonate 4, is used in household cleaning. Number 2, is used in confectionaries as a leavening agent, that is a raising agent, and it is also used in fire extinguishers. Number 7, sodium trioxocarbonate 4. This is also called washing soda. It is used as a common base in titration. It is also used in production of homemade laundry detergent. It is used in softening of hard water, and lastly, used in the manufacture of glass. Number 8 base that we shall consider is potassium hydroxide. This base is used for the manufacture of toilets, soaps, and bathing liquids because the product is softer and gentler on the skin than when sodium hydroxide is used for soap making. Potassium hydroxide is also used in the production of alkaline batteries. To conclude this series of lessons on bases, please write this down and do yourself this favor to ensure that you attend to it after the lesson. Create a chart of 5 bases and state the following. 1, name and formula of each base. 2, 2 uses of each base. I wish you a nice time after the lesson to enjoy yourself in whatever you choose to do. But please don't forget to do all your assignments. God bless you.